To be or not to be? This question has haunted Hamlet since the 17th century. To git merge or get rebase? This has haunted developers and programmers all over the world since 2005 when Git was born. In this video, we will try to demystify this age-old question of to merge or to rebase, because that is indeed the question. Both rebase and merge are concerned with one thing. How do you combine two branches into one so that the code is updated? And Git provides you with a merge strategy and a rebase strategy. The squash merge is related to a merge, but in this video we'll focus on these two only, merge and rebase. So rebase and merge are both concerned with combining branches. It's simple enough. Rebase and or merge both end up with the same result, which is a combined code base. So regardless of if you use merge or rebase, the end result is the same code. So what's the difference? Let's get into this. Merging. So let's say we have a master branch and we branched off of master to create a feature branch. And then we made some commits on the line, commit B, C, E. And while we're doing that, the master branch also was updated. Somebody, pushed some changes into it. Now, in order to get our feature branch up to date, we need to merge in the master changes, especially this D commit right here, into our feature branch. So we use the git merge master command on the feature branch. And what happens here? Let's take a look. So as you can see, the feature branch now, the commits have been updated. So the D commit is intertwined into the feature branch's commit. And also, by merging, it creates this new commit, F#, which is a completely brand new commit. So as you can see, it's simple enough. It takes all the commits from where we're merging, it incorporates it into our feature branch, and then at the end, it creates a merge commit. So how is rebase different from merging? Now, same scenario. We have our feature branch and master, and there's some commits in both. In the feature branch, we do git rebase master, and look what happens. So essentially, by running git rebase, we're indicating our branch that the base has been changed. So originally we branched off of A, but now feature branch is basing all of its commit off of a new base, which is the D commit here. So it takes this new tip and then it plays all of our commits. As you can see, B, C, E, B, C, E. But one thing to note here, when you actually rebase, it's creating brand new commits based off of your original commit. So now your old BCE commits are gone, and your new ones are replaced with a B0, C0, E0. So that's essentially what happens when you rebase. You get the new tip, base tip, and then you replay your commits by creating brand new commits that replace your old ones. So what is all this talk about rebase and the dangers of rebase, and why is it difficult to understand what happens? So let's take a scenario here. Let's say feature 1 hasn't branched off of master. Similar situation. So David created this branch and then he made some commits. Now let's say John comes along and then he extends our feature. He branches off of David's branch. And then as you can see here, BC is the original commit. And then he makes his own commits, X and Y. So later down the line, David decides to rebase because master branch has changed. And once you rebase it, as you can see, the new tip D, and then B0, C0, E0. David's commits have been played. But as you can see here, the issue with rebasing is the fact that your old commits are actually replaced with B0, C0, and E0. So as a result, your old BCE commits are completely gone. They're gone from the timeline, Git timeline. You can't retrieve them, they're gone. So when John bases off of BC, now he asks David, where are thou commits, B and C? And now there's a problem here. Because B and C commits don't exist anywhere in Git anymore, due to the fact that David rebased it, there's all sorts of conflicts. It's almost impossible to merge all these changes back in. So all of John's changes are not. They're most likely going to be thrown away, which is sad. So the golden rule of rebase is do not rebase any public branch or commits. Because rebasing is a destructive process and completely replaces your old commits, any old commits, BCE for example, that are pushed publicly should not be rebased. So if you rebase, for example, this feature 001 branch, do not consider rebasing because other people could potentially branch off of your branch and base their changes off of your old commits. So just to recap overview, merge creates an extra merge commit. Rebasing replaces all your commits with new ones. Merging, your commits are intermingled with all of your branch feature commits. Rebasing, your commits are based on the new tip. So all of your commits are played on the new tip by creating new commits based off of your old commits. Merging, history is not actually deleted. None of the commits are destroyed. But rebase, on the other hand, is a destructive process. Your old commits are replaced, and now your old commits are completely gone from the system. Merge. When in doubt, merge everything else. Rebase only when your branch commits are not publicly available and you haven't pushed anything to a remote repository. So I hope that gave you a general overview of the difference between merge and rebase. So now let's get to the live coding session. Let's actually see this in process and see what it looks like when you rebase and you merge your branch. Let's go. Okay, so let's take a look at merging. So what we're going to do is we're going to base a feature branch off of the master at a point, and then we're going to add some commits into that feature. And after that's done, there's going to be a change in the master branch, and we're going to try merging in master into our feature branch. And let's demonstrate that right here. So the first things first, let's add some commits into our local branch. So I'm going to add a condition in here, and the condition is going to be name equals Groot. And Groot is going to return, excitingly, hello Groot. Hello Groot. Now that will be our first commit. So I'm going to add that file, and then I'm going to commit. Added Groot to say hello. Great. Now let's add another commit in here. I'm just gonna add comments here. Excited to see Groot. Now, same process, git add, git commit, added, comment. Okay, cool. So now at this point, if you pull up the git log, if you actually pass in this pretty parameter, it just shows you one-liners, which is very convenient. As you can see here, we added the two commits right here. And this is where we started with. So our branch now, if you do status, is 2 commits ahead. Now, if you look at GitHub, and let's take a look at our master branch. So refresh this page. So I added a change in master branch to simulate this decommit right here. So the change is, in the say goodbye function, which is down here. I'm going to add the Gandalf condition, and if it's Gandalf, it's, responds with you shall not pass. Okay, so now as you can see, the master branch and the feature branch, they've diverged. So at this point in my feature branch, I need to take in all the changes in master branch and then make sure my feature branch is up to date. In order to do that, you check out the master and you pull. And you pull basically the most recent changes. So master is already up to date. Let's verify that. So yeah, master is already up to date. So now I'm going to switch over to my branch again, my feature branch. Modify say hello, and that's my feature branch. Now I'm going to merge in the changes in master. So the command is git merge, and you pass in the branch that you're going to merge in. So git merge master branch into mine. So before I do that, let me actually print out the logs just so I can demonstrate what it looks like to you guys pre and post merge. So let's just make that a screenshot to save it. Now to git merge master. Cool, awesome. So everything worked properly. There's no errors. So let's take a look at the git logs now and compare that to what we originally had. Aha, so as you can see, the Gandalf in the goodbye function commit, which was what master was, is right here. It's added here. And now the two commits that I made locally, adding Groot to say hello, and the comment above it, that's also here. And if you can actually see, the commits are exactly the same commits, right? 0C37, 0C37, EB6F, EB6F. And also, along with those changes, it added this merge commit. As we mentioned, git merge, if it always adds a commit. A side note to that is if it's a fast forward merge, it's not going to, but we'll talk about fast forward merging in future videos. Let's just take a look at the not fast forward method. So git merge, generally by default, it will create this new merge commit. So as you can see, all the commits in master has been intertwined with our local branch. And now our branch is up to date. It has all the changes that master has. So for example, if you go to the say goodbye function, indeed, so this is the function or the condition that I added, the Gandalf condition that I added in the master branch, and now I'm seeing it locally in my feature branch because I merged those changes in. So yeah, at this point, the merge is complete. You know, you can push this whenever your feature is done. You can push this, and it's all good to go. So that's merge in a nutshell. Hopefully that was helpful. Let's move on to the next one. Okay, now let's take a look at rebasing instead of merging. So I reverted my changes, so we're back to the starting position. So I'm going to add my commits again. So I'm going to add Groot into this function. The name equals Groot. And then I'm going to return hello Groot. I'm very excited. Now that's the first commit, so I'm going to add and then commit. We've all seen this. Repeat the step. Now I'm going to add a second commit to the feature branch, which is excited to see Groot. Once that's complete, I'm going to add another commit. Okay, great. Now we're at a point where the feature branch, we added some commits, and the master branch, just to reiterate, the master branch we added, remember that Gandalf function, or in the say goodbye function, we added Gandalf as a condition. Right now we don't see it because it hasn't been merged in, or it hasn't been rebased into our code. So we're gonna go ahead and do that. So let's take a look at the history, or the git log real quick, and I'm gonna save this using the snipping tool. So I can compare it. But let's see what happens when I rebase. Git rebase, the command is git rebase, and you pass in the branch name. So I'm going to rebase master branch into my feature branch. There we go, successfully rebased. So if I take a look at the logs now, interesting. So we had our E8D59, which is adding Groot to the say hello function. We had 2A472, which is adding the comment. But if you actually take a look at git logs, those commits don't exist anymore. So what happens here is our original commit, let's say hello Groot, actually was replaced by a new commit. And same thing with the commit as well. So what happens here is the new base here is the new tip of the master branch. So when you did a git rebase, it looked at, where is my new tip that I'm going to base my feature branch off of. And indeed, it took a look at the master branch. And here, this 0E89 is the new tip. And once that new tip is set, it replays your commits. and then it replaces your original old commits into a new one, and then just plays it back. So that is essentially what rebasing looks like in action. So in this case, we're fine, right? Because we stuck to the golden rule. We didn't push anything to the feature branch. So feature branch, if you look at it, it's old. The commit is very old. This is before the 2 commits that we made. So we didn't break the rule, and then rebasing worked perfectly fine. And at this point, you know, if you're sure that your feature is good to go, you can push this branch, and there would be no issues. For example, git push origin feature branch, and so this is gonna push all my changes upstream to GitHub without any issues. So if you actually take a look at this and refresh the feature branch, there we go. You can see we added Groot to say hello, which is that new commit that Rebase created, and then the new commit that Rebase created. Now, as you can see, your old commits no longer exist in the Git timeline, and they are gone forever. So that pretty much concludes rebasing. Now, let's take a look at rebasing, or let's break the golden rules and actually see what happens. Okay, so now we looked at merging and rebasing. We're going to break the golden rule of rebasing. We're going to push some commits publicly. We're going to push it upstream, and then we're going to actually try rebasing that feature branch and see what happens. So I reverted all the changes. So if you do a git log, you see that I'm, you know, at the starting point. And same thing here, my feature branch, I reverted all the changes, so I'm at the starting point 702. So now I'm going to do the same thing. I'm going to add Groot into say hello. Else if name equals Groot. Adding Groot. There we go. And I'm going to return hello Groot. Now I'm going to add this commit. Added Groot to say hello. And at this point, you'll see that indeed that commit has been made. So let's break the golden rule. So I'm going to push my branch upstream and pass in the branch name. And then after I do that, I'm going to make some more commits. So that has been pushed. And if you just to verify, you can refresh GitHub, check on the branch, and indeed my commit has been pushed. So at this point, I'm going to now make more changes locally. I'm going to add excited to see Groot. Now that's my change I'm going to make. I'm going to add this file and I'm going to commit. Added comments. Great. Okay, so now at this point, as you can see in the logs, we have the function, the say hello Groot condition that I pushed upstream, and now a new commit that just adds the comment. So at this point, let me rebase with master now. So once again, master, remember we added the Gandalf function, or the Gandalf condition, into the goodbye function. So I'm going to rebase. So I'm going to do actually going to do this the right way. So I'm going to just pull, make sure master is indeed up to date. Once you do that, you check out to your feature branch. And in your feature branch, you run the command git rebase master. Cool, so everything worked correctly. So everything's good to go, right? Because everything worked correctly. There's no errors. Let's take a look at the logs. Cool, so the commits. So there's these new commits that I made. And this is the commit in the master branch that I'm basing it off of, the new tip. So at this point, you know, you're good to go and you say, hey, I'm done with my feature. I'm going to push it upstream. Now, you're going to see an error when you do this. Boom. Failed to push some refs. Updates are rejected because the tip of the current branch is behind. So what is this error message? The reason why this error message pops up is because your commits don't exist in Git anymore. Remember how Rebase completely rewrites history. It takes your original commits and it replaces them with new ones. So if you do a git log, when I go to my feature branch in GitHub in my remote repository, let's refresh that. As you can see, the added Groot to say hello function is the 6b72 commit. But when you check out our git log locally, that doesn't exist anymore, remember, because we rebased it. And that's the reason why Git catches this and says, hey, something is wrong. Like you have a commit up here, but locally your commit doesn't exist. It's something's wrong. I can't push right now because I don't want to mess things up. Now that is what we're talking about when we talk about removing the Git history, when we're removing commits outside. Furthermore, to that point, if let's just say another developer comes along and then branches off of your feature branch. So let's say he creates another branch here based off of your feature branch, 001 extending say hello. So this is a completely new developer. So now that branch is created. Once you push this, let's just say I could push this. So I'm just gonna force this change and say, oh, it's okay. It's gonna be fine. And I force that push into my feature branch. So what Git is basically, Git's gonna ignore the error that I was throwing before and then do push what the state of the local commit is remotely. So when I look at my original branch and look at the commit history, you see everything pushed because I passed in the F flag, the -F, which is the force flag. But now there's a problem because this new developer that branched off of my old branch or my old commit now has a commit there that doesn't exist anywhere in the system. Now it's gonna be a real problem, trying to merge this back in, and then potentially hard work will be lost. So now I just demonstrated you, the golden rule. If you break the golden rule, there's real possibilities of lost code or lost work. So just make sure when you rebase to ensure that everything is local, most likely. So if you just keep that in mind, and if you keep in mind that nothing was pushed outside publicly, it's fine. In your feature branch, you can rebase as much as you want. Let's just say there's more additional changes in master branch in the future. You can just keep rebasing it. Rebase. As long as nothing has been pushed upstream, or you even, or some other developer hasn't branched off of your feature branch. If you just make sure of that, then rebasing is not a problem. Great, so I hope that was a little bit more helpful. I think for me personally, it really helps just going through this live coding and then just kind of working out the function, the commands, and then seeing the different error messages. So yeah, let me know what you guys think about rebasing and merging. Thank you for tuning in, and see you guys soon. Alright, if you guys enjoyed that video, please like, comment, and subscribe. Like, comment, and subscribe. Like, comment, and subscribe. Wait, how long am I doing this? Like, comment, and subscribe. Like, comment. Okay, I'm done.